So in order to help you be successful in doing fractions, what we're going to do is go through the rules first, and then we're going to give you guys some time to practice today. So our rules start with adding and subtracting. Again, the hard part on this is your rules are different based on the operation. So the first thing you need to do when you're doing fraction work is figure out which operation you're doing so that you can put the appropriate rules with it. Yes, David?
What if you're leaving? We have to do what? Like I'm leaving in 2 days.
It's okay because you're registered with the DMS. It should be open all summer, so you're still good. Okay. Now, when I'm adding and subtracting fractions, your first, guys, listen. Your first and most important rule is all fractions must have a, good, who was that? Is that your journey? Good job. A common denominator. So, in order to get that common denominator, anything that I do on the denominator to get it common, I must also do to the numerator. Okay? Now, and here's the other really kind of funky part about this. Once you have done all of the work to get that common denominator, you actually don't do anything else with the denominators. You're only doing the operation, addition or subtraction, to the numerator. Okay? And our last step is to simplify. You're always going to simplify. That includes, especially if you're adding fractions, if you end up with an improper fraction, turning it back into a mixed number. So we'll work some more on that in a little bit. Any questions on adding and subtracting the fractions? Okay, our next one is multiplying. Multiplying is the easiest operation to do with fraction, guys. This is super simple. All we need to do is look for common factors on the top and the bottom to make our math easier. So what are our 4 key numbers we're looking for to find common factors?
2, 3, 5, and 7.
Good job, Sola. So we're looking for those 4 key numbers, 2, 3, 5, 7. That's mine. Okay, we're looking on top and bottom to reduce. The reductions are going to make our math easier because it's going to give us our answer in simplest form. We're also then looking at getting smaller numbers. So our math, multiplying the numbers, should also be easier. Once we have all of our reductions done, now we're going to multiply top by top and then bottom by bottom, or numerator by numerator, denominator by denominator. And once again, we simplify. Again, if you did your reductions, simplification would only be turning it back into a mixed number. If you didn't simplify, you may need to be doing a lot more work. So look for those reductions. It's going to make your life easier in all aspects in the long run. Questions on multiplying? Okay, our next one is our dividing of fractions. This one, we really can't divide fractions. Remember? Just doesn't make sense. So instead of dividing fractions, we have a first step. That's our keep, change, flip. So we're going to rewrite the fraction so that I can multiply by the inverse. In order to rewrite it, that's our keep, change, flip process. So remember, what we're doing is multiplying by the inverse. The process is keep, change, flip. Does that make sense? So our process is keep the first number like it is, change the division sign, and you cross that second one out, I got a typo there, sorry, to multiplication, and then flip the second number to its inverse. Now we're going to treat it just like multiplication, including looking for reductions, because this is going to allow us to get our answer in simplest form. Careful on the reductions. You cannot do reductions in division form. You have to wait until it's in multiplication form to do divisions, to do reductions. Can't do reductions until it's in multiplication form. Make sense? Then once again, we're going to simplify if you need to. Questions on any of those? Add, subtract, multiply, divide. 4 separate rules that you need to make sure you have straight. Okay, let's look at our next page. Here's one we really have not done much with so far this year, and that is mixed numbers. So let's talk about it real quick. I'm going to give you 2 options on doing these mixed numbers. The first one is by far my preferred method because it's going to make your math a lot easier. Second method will work, but you'll see, especially with some of the numbers we've got today, it gets really nasty really quickly if you try to do our second method. The first method is I'm going to take the fraction pieces of our mixed numbers out, and I'm going to do the operation just with the fraction pieces. Okay? So if subtracting and the second numerator is bigger than the first, I need to borrow from the first whole number to make the first numerator larger. Okay? I'm going to borrow the amount of the denominator. So really what we're going to do is add the numerator and denominator of that first fraction together to get your new numerator. And we're going to talk a whole lot more about this in a minute. So for right now, just write it down. Once I have done that, now I can actually do the subtraction. Once I've finished with the fraction portion, then you're going to add or subtract the whole numbers. And then I'm going to put the new whole number back together with the fraction portion that we got from the fraction division, subtraction or addition. Okay? So what does this look like? Because this is going to help us understand this a little bit more. So let's say I'm going to take 5 1/4, and I'm going to subtract 2 7/8. Okay, our first step, we're going to pull out the fraction pieces. So I'm going to do 1/4 minus 7/8. Okay, let's do a quick side step. If I'm going to do 23 minus 18, what do I have to do? Can I do 3 minus 8? No, so what do I have to do? Borrow what? Borrow from the 2, but what am I actually borrowing? 10, right? Because I'm borrowing from the tens place. Does that make sense? So I'm actually borrowing 10, and I'm adding that 10 to the 3 to make that a 13. Is everybody okay with that? Everybody okay with that? Anybody not okay with that? So what am I now doing? 13 minus 8 is? 5. Is there anybody who has a heartache with doing that? So everybody's comfortable with that, right? If I didn't have enough in the place I was at, I just borrowed from the next place to give me enough to do the subtraction. Everybody's good with that, right? Okay, keep that thought in mind for a second. Now, I now have 1/4 minus 7/8. What's the first thing I need to do? Common denominators. So that's going to be what? 8. So I'm going to do times 2. So that now gives me 2/8 minus 7/8. Everybody tracking so far? Can I do 2 minus 7? No. So what am I going to do?
Take 1 away from 5 and...
So I'm going to borrow. So what did I just borrow? 1 whole. Now here is the beauty of fractions. I just borrowed 1 whole, right? So if I am now have 1 whole, I can make that any fraction I want to, right? If I made it halves, how many halves would I have? 2 halves, right? If I had fourths, how many fourths would I have? 4 fourths, right? Could I make it eighths?
Yes.
How many eighths would I have?
8.
Is everybody okay with this?
Yeah.
Because I have borrowed a fraction, I can make it anything I want to. I can cut that 1 whole number up in any amount of pieces I need to. Is everybody okay with that?
Yeah.
But what's my numerator going to be? whatever my denominator is. However many pieces I cut it into, my numerator and denominator are the same. Everybody good? Okay. In this case, my common denominator was 8. So how many 8s do I need to borrow out of that 1? 8 8s. So really, in reality, all I'm doing, guys, here's where this piece comes in. All I'm going to do is add the numerator to denominator, because this, the denominator, is how much I'm borrowing. That's why you get the common denominator before I borrow. Make sense? So now, all I'm going to do is add those together. That 2 now becomes a 10. Just like we did here, I crossed it out, and that 3 became a 13. My 2 now becomes a 10 because I did 8s instead. I borrowed from a 1 instead of a 10. I didn't add 10. I added the 1 whole, in this case, 8 8s. Make sense to everybody? Okay, so now I can now subtract 10 minus 7 is 3 8. So that's the fraction piece. Now I do the whole numbers. This is borrowed, so it's now a 4. 4 minus 2 is 2 and 3 8. Everybody feel okay with that? Okay, let's do one more just to help you out a little bit and make sure we're good. So let's say I'm going to do 7 and 1/5. I'm going to take away 2 and 3/4. First step, let's pull our fractions out. So we're going to take 1/5 minus 3/4. What's my common denominator? 20. So I'm going to do this one times 4, this one times 5. That gives me 4/20 minus 15/20. Can I do 4 minus 15? No. So I'm going to borrow from the 7. I make it a 6. I borrowed 1 whole. How many pieces am I going to cut this whole into? 20. Why? Because that's what my common denominator was. So what I'm doing is I'm adding the 4 and the 20. That becomes 24. Because I borrowed 20/20. So the 20 plus the 4 gives me 24. Now I can subtract. 24 minus 15 gives me 9/20. Go back to my whole numbers. Excuse me. 6 minus 2 gets me 4 9/20. Is there anybody who doesn't see what we just did? Is there anybody that doesn't make sense to? Getting the common denominator?
No, the 4 crossed out.
Okay, because when I borrowed from the 7, I borrowed 1 whole, right? But I can't add a 1 to a fraction, but I can cut that 1 into however many pieces I need to, right? So how many pieces do I need to get a common denominator? 20. So what I did is I took 20/20, or that 1 that I borrowed, and I added it to that 4/20. So common denominator, all I do is add the tops. 20 plus 4 is, make sense?
Yeah.
Good question. Thank you. Okay, so here is our second method. Oh, I thought you were talking to me. It's like I'm not sitting. Find a common denominator for the fractions. Okay? Turn both mixed numbers into improper fractions. That's our slam dunk. Everybody remember that? Unfortunately. Once I've done my slam dunk, I'm going to add or subtract the numerators. And then I need to simplify. So you're going to see there's a lot more work to this. Okay? So our first step, find common denominator for our fractions. So I'm going to use the same numbers. 5 and 1/4 minus 2 and 7/8. What's going to be my common denominator for the fraction piece? I have 1/4 and 7/8. So my common denominator would be 8. So I'm going to multiply this one by 2. So that gives me 5 and 2/8 minus 2 and 7/8. Now that I have a common denominator, I'm going to slam dunk. So we're going to multiply the bottom and then add the numerator. on both of them. That gives me 8 times 5 is 40, plus 2 is 42. So 42 eighths. 8 times 2 is 16. 16 plus 7 is 23 eighths. Excuse me. I need a drink. So I do 42 minus 23. That's going to get me 19. So that becomes 19 eighths. And now I have to simplify. How many times will go into 8? 8 go into 19? 2 with how much left over? So you can see I was able to get the same answer. Oh, thank you. Get the same answer. It's just, to me, this is a heck of a lot more work. You can see all the different areas we've got chances to make math errors now, right? I can make a math error here as I'm changing my fraction. I can make a math error here as I'm going to the improper fractions. I can make a math error here as I'm doing the subtraction of the bigger numbers. And I can make an error here as I'm returning it into a mixed number. Whereas on the first one, I really only have a couple chances to make an error, right? I can make an error here. I might make an error here if I'm adding wrong, but that's really rare. I now have much smaller numbers, so the chances of making a math error as I'm going here are much smaller. And now I'm just doing 4 minus 2. You guys should be able to do that one without math errors. Wow, David's confused. Anyone else surprised? Does this make sense? So you have your option, whichever way you want to do it. But we're basically going to give you guys the rest of the time in class today to work through this. So you got 3 pages to do. Go ahead and start on the next page. You may compare answers as a table. I recommend you work it out on your own and then compare answers. That's going to be your best bet to make sure you get this down correctly. So go ahead and get to work, guys. Okay, many of you are apparently still struggling on this, so let's talk about exactly what we're doing on each of these, okay? Very first one, really simple. Division is their keep, change, flip. Keep, change it to times, flip. 3 over 2. No reductions on this one, so I just multiply. 1 times 3 is 3. 2 times 2 is 4. Subtraction, common denominator. These are going to meet at 20. So I'm going to do times 2, times 5. Rewrite them, guys. I see a lot of you that are avoiding the rewriting step. It's going to cause you trouble in the long run. Just rewrite it. That's not that hard. Is it, David?
Yes.
Really isn't. So 18 minus 5 gives me 13. Don't do anything to the denominators once you have a common denominator. Adding, that means common denominator. So going times 3 times 4. 3 twelfths plus 4 twelfths gives me 7 twelfths. 10 and 30, that's going to meet at 10 and 3 is going to meet at 30. So times 3 times 10, 18 and 20 gives me 38. I can divide that one by 2. Gets me 19 over 15, or 1 and 4/15. Okay? This one's going to meet at 10. So 8 tenths minus 8 tenths. Anytime I have a number and I take that number away, I get 0. Doesn't matter if it's fraction, decimal. Anytime I'm subtracting what I've got, that's a 0. So I have 1 tenth and 8 tenths. Gives us 9 tenths. Multiplication, easiest thing we can do, guys. All I need is reductions if I can. 1 times 1, 3 times 3. If you don't do reductions, that's okay. That just means I do 1 times 2 is 2, 3 times 2 is 6, which I can then simplify by 2. You'll get the same answer, just more chances to make a math error. Okay? So if you're not comfortable with reductions, just do the math. But I hope you'll get comfortable with the reductions if you're not comfortable. I'll put it that way. So I'm dividing those by 2's. 1 times 3 is 3. 2 times 5 is 10. Subtraction again, so I need a common denominator. gives me 10/15 and 6/15 or 4/15. Division, that's my keep change flip. 4/5, 10/1. I've got one reduction I can do. Divide those by 5. Gives me 8/1, which simplifies to 8. Whoever has a rubber band or whatever, please stop snapping it. Okay, another one here. We've got a reduction of 2. 1 times 7 is 7. 4 times 5 is 20. Here's our another keep change flip. So 2/4 times 2/1. I've got a couple of reductions I could do. Gets me down to 1s all over the place. So 1/1, which equals 1. Any questions on our first page? Okay, let's look at page 2. Addition on the first one, so that's a common denominator piece. So multiplying by 3 and 4 gets me 9/12 plus 4/12. Add up my numerators, gets me 13/12, which will simplify to 1 and 1/12. Tenths, so this is going to be times 5. Gives me 5/10 and 8/10, or 13/10. Simplifies to 1 and 3/10. This is going to be at 20. So multiply by 5 and 4. Gets me 15/20 minus 4/20. 15 minus 4 is 11. It's going to be at 15 again. So that's going to give me 9/15 minus 5/15, which is going to be 4/15. 1/2 and 2 and 5 is going to meet at 10. So times 5 times 2 gives me 5/10 plus 8/10, or 13/10, which again simplifies to 1 and 3/10. Another division, so that's going to be my keep change flip. 1/2 times 3/2. No reductions that I can do, so that's just simple, straightforward 3/4. Another division, so a keep change flip. 1/2 times 3/2. It's actually the same problem, so I should have gotten that one by now. Multiplication, that's the easiest one. I don't do anything. Just 1 times 1 is 1. 2 times 4 is 8. This one I do have one reduction I can do. 1 times 1 is 1. 1 times 4 is 4. Another one here, we've got 4s that we can reduce out. 1 times 2 is 2. 1 times 5 is 5. Another subtraction, so we need a common denominator. In this case, it's going to be the tenths again. 5/10 minus 3/10 gives us 2/10, which I can now simplify by 2 for 1/5. And another division, so that's our keep change flip. 1/2 times 3/1 gives us 3/2, which simplifies to 1 and 1/2. Any questions on the second page? Okay, hopefully if you didn't do these, you've been writing them down. Well, you're supposed to have them done. Okay, our last page. Here's where we're going to start. I'm going to do option 1 because that is far easier, in my opinion. So I'm going to pull out the fraction piece. 1/2 minus 1/4. So to get to a common denominator, I need to multiply that one by 2. Gives me 2/4 minus 1/4, which is 1/4. Then I do the whole numbers. 5 minus 3 is 2. This is the one where if you're doing improper fractions, it gets really nasty. So hopefully you're coming over to the dark side here. 19/32 minus 20/32. Can I take 19 and subtract 20? Nope, so I have to borrow. Borrow from the 8. I'm just adding these two together because I'm borrowing 32 over 32. That gives me 51. So 31/32. And then I have an 8 minus 3 gives me 5. 5/16 minus 1/4 Do this one times 4 for my common denominator. So 5/16 minus 4/16. That one I can do. That's just 1/16. Then I do the whole numbers. 4 minus 2 is 2. Next one, 1/8 minus 1/2. For our common denominator, we're going to go to 8. So that's going to be 1/8 minus 4/8. Can't do 1 minus 4, right? So I borrow from my 9. I'm borrowing 8/8. That makes this a 9. 9 minus 4 is 5/8. I now have 8 minus 2, which is 6. 1/2 minus 1/2. Any number, anytime I subtract a number by itself, I know that's going to be 0. So I just do the 6 minus 2, which is 4. 1/8 minus 9/16 times 2 to get me to 16. 2/16 minus 9/16. Can't do 2 minus 9, so I'm going to have to borrow. That now makes that 18 because I add the 16 into 2. So that's going to be 9/16. Now 5 minus 2, which is 3. Now we're doing 30 seconds. So 1/2 minus 21 over 32. So that's going to be times 16 to get to 32. So I've got 16 30 seconds minus 21 30 seconds. Can't do that, so I'm going to have to borrow. Borrow 32 gives me a 48. So that's going to be 27 30 seconds. And 3 minus 2 is 1. 5/8 minus 13/16. That's going to be times 2, so I've got 10/16 minus 13/16. Can't do that, so I'm going to have to borrow again. Borrowing 16, so that's going to make that a 26. So that's going to be 13/16. 6 minus 3 gets me 3. 3/4 minus 3/4. Just like we had earlier, anytime I subtract a number by itself, that's going to be 0. So I'm just doing 7 minus 3 is 4. And then our last one, 1/2 minus 3/8. So that one's going to go times 4. It's going to give me 4/8 minus 3/8. That one I can actually do. That's just 1/8. So I just do the whole numbers. 5 minus 1 is 4. Questions on this page? How are you guys feeling on those mixed numbers? Thumb meter? Nice. Liam, no opinion? Okay. So overall looks pretty good. Okay, your homework. This one should be relatively easy. We've got another great dad joke. Why does a mermaid wear goggles? It is funny. Oh, I had to explain it to Miss McShann, so.
What? You did not. Don't even start with me.
It's really easy. All you're doing is adding, or I think these are all adding or subtracting. So 1 and 3 gets me 4/4. That simplifies to 1. So anywhere in here I see a 1, I put an S. Now there is one difference in this one than a lot of the other ones we've done. It's segmented. So these answers only apply to these. There are also going to be some blanks in this one. That is intentional. The blanks are going to separate the words, so you can actually get the message very clearly on this one. You don't have to try to figure out where the word breaks are. Okay? So once you've done all of these, you'll get a message so that you understand why mermaids need to wear goggles.
It's not funny. I don't even understand.
It is, though.
It's not.
Okay, any questions on the math piece of it, guys? Because it was first. Any other math questions? Okay, so anytime we have left, you guys can work on